In this video, we're going to look at example 4 on our notes and examples from 3.1 on the definite integral. So for number 4, it says use the idea of area to determine the value of the integral from 1 to 3 of 1 plus x dx. So what we've seen so far in the examples are how to estimate areas under curves using rectangles. But for this problem, we actually don't have to do that. We can find the exact area under the curve. So let's go ahead and see why. So to do that, let's graph our function 1 plus x. So we see that's just an equation, or that equation is a linear equation. So our graph looks like a line. Our vertical intercept is 1 here, and our slope is 1. So the curve will just go over 1, up 1, over 1, up 1, over 1, up 1. So let's draw that in. So it looks something like this. Excellent. Okay, so that definite integral from 1 to 3 says that we want the area from 1 to 3. We want the area between the curve and that x-axis. So this is going to be where we will find that area. So let's see how we'd go about computing that area explicitly. I'm just going to fill it in so we know the area that we're talking about here. So we see that the area under the curve forms a nice shape with these straight lines. So we can break up our shape so that it's easier to compute the area. So we see that we can see a square here. And I'll outline it with my laser. And a triangle. And we know how to compute areas of squares and triangles. So we can see that the square has a length of 2 by 2. So the area is going to be equal to 2 times 2, which is 4. And we also have this triangle up here. Now the area of the triangle, well, the width is 2, the height is 2. So the area is going to be equal to 1/2 base times height. So 1/2 2 times 2, which is 2. So then in total, we know that the integral from 1 to 3 of 1 plus x dx is equal to the sum of the square and the triangle. The square is 2. The square is 4. The triangle is 2. So in total, we have an area of 6.